We begin by plugging in pi over 2 and see what happens. Now secant of pi over 2 is undefined because it's 1 over cosine of pi over 2. And so we actually just look at what's happening from the left and the right. So as x approaches pi over 2 from the left, then secant approaches positive infinity. So this is infinity. And then minus, and then the tangent of pi over 2 also approaches infinity. So that's infinity minus infinity. And as x approaches pi over 2 from the right, then secant approaches negative infinity minus, and then tangent of pi over 2 from the right is a negative infinity. So it's negative infinity plus infinity. So they're both of the form infinity minus infinity. And for that indeterminate form, we look for ways to either factor or combine like terms. Just we're looking for some algebra to change the form of it. So because we've got trig functions here, I'm going to write this all in terms of sine and cosine. So secant of x is 1 over cosine of x, and then tangent of x is sine of x over cosine of x. And that shows me, oh, those can actually combine. They have the same denominator already. And so we have 1 minus sine of x all over cosine of x. And now this is again of the form 0 over 0. And so now we can use L'Hopital's rule. So we can take the derivative of the numerator, which is negative cosine of x, and the derivative of the denominator, which is negative sine of x. And plug in pi over 2, we get 0 in the numerator and negative 1 in the denominator. And that's 0.